Hello friends, welcome to my channel. In today's video, we will cover most important AI technique which is helpful in modern search systems and conversational AI. The topic we'll cover in today's video is Retrieval Augmented Generation, or we can say it simply RAG. Traditional language models are smart, but they have a serious limitation, like they don't know anything beyond what they are trained on. That is where RAG comes in. By combining semantic search and Gen AI, RAG allows language models to retrieve real-time factual information. So you can feed your document as a knowledge source, and it will generate you highly relevant, accurate responses, which is grounded in that data. So in this session, we will cover how semantic search works using word embeddings and vector similarity, and how to build and use a vector store, and what happens behind the scenes in a reg pipeline. So we'll cover whole reg pipeline and how it works. So whether you are a data scientist or a developer or just a AI curious person, this tutorial will help you to equip with practical know how to build smarter data aware AI system. So without any further discussion, let's get started. So here you can see this is the basic reg pipeline in which data is ingested, and again it is processed with retrieval system, and again it is providing response. So let's move to the other page. What is reg? So we'll know like what is reg and why it is important. So reg is an NLP architecture which combines retrieval based methods with generative AI models. It enhances the generation capabilities of LLMs by allowing them to access external knowledge source like vector databases or document stores. It can be in any form, PDF or Word or in Excel form. Okay, it the traditional language models were limited to their training data because of the storage and other things, while RAG solves this by retrieving relevant documents from knowledge base and using them to generate more accurate and up-to-date and context-aware responses. Okay, so basically it is the combination of both the classic NLP models and the Gen AI model. So you can see here, this is the basic RAG pipeline where the data is ingested, and again it will create this document information into a chunks, and again the process will be happen to these chunks, and it will convert this into embeddings. Again, after embeddings, it will provide it indexing, so that whenever a user will ask any query, so it will just follow this indexing and provide the right answer. Okay, this is the second step where retrieval is happening, where user's query will be again converted into chunks, and again the same process will happen. It will convert this into indexing, and also get top K responses. And again, it will be synthesized the synthesis will be happen with LLM and will revert into the response. These are reg pipeline important components which we will use it to build the reg pipeline, where we'll go in the reverse mode, where user will ask you a query or write a query. So here I have taken example of what are the effects of climate change on Indian agriculture. So user is just providing this prompt, and what retriever will do, a retriever will retrieves all the relevant documents from a knowledge base where we have fed the data. It can be in any form, on PDF, Word or Excel or any form. Okay, see, these are the stores like FAISS, Elasticsearch and Viviet. Again, it will go to the third stage where re-ranking will be happening, and this is optional, but generally we should use it because see, if there are more than 10 or even large number of relevant documents will be there, then what it will do is it will just score it and it will apply sorting to the documents. So where top 5 or top 10 documents will be finalized, and from those finalized document it will provide you on a response. So these are the tool or model we can use to process this step. Again, it will go to the generator step where LLM models will be used. Here, it will use the query plus document. So it will match the query with the document chunks. Okay, and after this process, it will provide you the response. So it will use any models like GPT-4 or any models of GPT 3.5 or any. Llama 3 is there, Mistral is there, and again it will go to the final step where again that response embedding response will be converted to readable format. So this will be your output, so it will be in the accurate context rich response, so that here you can see this will be the answer by models. So climate change affects Indian culture by so. Okay, let's move to the. So again, it will consider this document as well as query, and both these queries and documents will go to the next level, which is your LLM model will be applied here, and it will provide you a more accurate and in a user-friendly user-friendly prompt. So this will be your final response. So this is the process of reg pipeline, and you have to follow all these steps. Okay, this is the rec plan step by step where we will build the vector store. You can see here, like we have seen this step before this slide. And the main purpose of building vector store is here you are creating a searchable database of vector representations of your knowledge base. So, for example, if you are providing some data in the form of PDF. So it will be automatically it will create this into vector database, and it will be stored in the vector store. Okay, so basically it will convert those chunks into numerical vectors, so that that model will be just matching that numerical form, and it will like it will not just process that meaning that similarity of that word, but it will also consider the meaning of that word. Okay. The knowledge source for this step could be a collection of documents or knowledge graph or a database or even specific websites on the internet. So this step will typically utilizes a pre-trained embedding models like SentenceBot to transform each text piece into a vector. So once the embeddings are generated, these vectors can be stored in a specialized database which is optimized for similarity search. So it will just consider the similarity score for further process, and this vector store enables efficient retrieval of relevant information, which is based on the semantic similarity rather than just a keyword matching. So it is just enhancing the classical NLP models into advanced one. Then we'll move to step two. Here in this step, you will embed the query and perform a semantic search. So these are three main steps which you have to follow during building a RAG pipeline. The main purpose of this step is to retrieve the most relevant documents to the user's query. So in this step, the user query will be converted into a vector using the same embedding model which is used for the knowledge base. The same process will be happen here as well. Then a similarity search is performed in the vector store to identify the most relevant documents, or we can say it chunks to the query. This is done by comparing the vectors of both the query and the document information using distance metric. Usually, we can say that cosine similarity. So this step effectively retrieves information or documents that are semantically closest to the user's query, and it will ensure that it will only use the most relevant information from the knowledge base, and it will be used to generate the response. So the here it will make sure that you will get the highest accurate information. So we'll move to the step 3. Here you are passing the prompt with the query and relevant documents to a large language model. So as we have seen the process of reg in previous slide, the purpose of this step is it will generate an accurate and informative response. So after completing step 2, the retrieved documents along with the original query, which will be combined into a prompt and fed to a LLM. Okay, here the LLM processes this information and it will generate a response that incorporates the retrieved knowledge. And this step will be again use two main components, which are prompt engineering and LLM inference. So in prompt engineering, the relevant documents and the query will be structured into a prompt that provides context and guides of the LLM's generation process. Okay, and LLM inference will be like the prompt will be passed to the LLM, which generates most accurate response based on its understanding of the query and retrieved knowledge. So the LLM leverages its language generation capabilities to provide a coherent and informative response while ensuring factual accuracy and grounding its output in the retrieved documents. Okay, so basically we can say that LLMs are trained on historical data, right? So it is not the real-time data we are feeding to that model, right? But by leveraging this thing with reg process will feed relevant and real-time data to LL models, and it will consider both historical data and knowledge source data, which is real-time data, or whatever data we have fed to the document fed to the model as a knowledge source. So it will combine both these things and provide you most relevant information. So during the whole process of reg pipeline, document chunking and relevance scoring, these are most important considerations, because see, document chunking will breaking down the large documents into smaller chunks before the embeddings process to improve retrieval accuracy or efficiencies, and that relevance scoring or ranking will further refining the retrieved result. We can say documents or text chunks based on factors beyond semantic similarity, which are document recency and metadata, which is filtering or source reliability. So these are main things you have to consider before at the time of building reg pipeline. So you can see here I have considered these steps into detailed form, where you are building a vector store, which here you are creating a searchable database. This is the real world example I've taken, which is of customer support board. And the problem is your users ask questions not covered in the training data. So, the as I've told you earlier, the real LLMs are trained on historical data, so it is not the latest information it is providing. For example, if it has been trained before 6 months, then it will provide you the data or answers which will be happened before 6 months. Okay, and if you are providing the data after those 6 months, which will be latest data till yesterday or till today or till right now, so it will consider all the things together, and it here by using this data you are creating reg pipeline. Okay, so if user will ask like how do I reset my password? So Retriever pulls password related KB articles or latest articles, right? So generator uses pooled documents to create a helpful, accurate response. Okay, so by using this reg pipeline, it will provide you most relevant answer. Again, the main important topic during reg uh, learning is semantic search system. So again, I have converted into small part of reg. So here you can see if this is a query. what are the features of latest iPhone, right? So as I told you, if you are using direct LLM, then it will consider the information of iPhone before 6 months, or like before when the LLM was trained. Okay, but what if I needed it like if yesterday or before a month, if a new product of iPhone has been launched? Okay, so here, what is the like if you are using reg pipeline, then see here are the documents. This is the document one, which is considering Apple product overview of 2023, and again it is providing details of latest pro tech specs of iPhone 16 Pro, and this is the document 3, which is considering Apple company's profile. Okay, so this three documents, currently I'm taking it as an example. This three documents will be stored into vector space. So here you can see this two process can be this is already happened, we have already built a pipeline where these documents will be used will be go to the embedding models, and it will be converted into embeddings, and vectorization has been processed here. Okay, so you can see here it will be stored in vector space on the basis of their vector number. Okay, again at the time of query asked, it will again process like it will go to embedding models and convert this query into chunks and embeddings, and it will find the information. So what are the features of the latest iPhone? So what it will do is it will find the relevant matching semantic search from this store. Okay, so here you can see it will consider all the three information from the document, and this is the document one is providing more nearest response. Okay, you can see here these two documents are little bit far away from the it is not matching with the score, so that it will consider this document and provide you as provide you response on the basis of this document one. Word embeddings, which is the vector representation for words, and with this is a very powerful tool in NLP. It is allowing us to capture the meaning of words in a way that can be used by machine learning. So this by using this numerical form, you can do a subtraction or addition or whatever process to find the relationship between the words. Okay, so here it is, see initially what was happening, in previous classical LLM NLP models, if user will ask query related to cat, then the model will be performed this query and process some task and provide you answer if it is if it is completely matching with this user query. Okay, but right now see what is happening. You can match you can use this vector store and embeddings. It will find the relationship on the basis of this numerical version. Okay, so these embeddings will help you to do some process addition, subtraction, or any other process to find the cosine similarity. Okay, so it will, if it is matching with the user query, then it will provide you answer in that by using those particular documents. So word embeddings are a way of representing words as a vectors in a high dimensional space, where each dimension corresponds to a feature, or we can say a set of feature. Here you can see this living being, feline, human, gender, royalty, verb. These are a set of features. So the key idea behind the principle of word embedding is that see words with similar meaning and context tend to be grouped close together in a high dimensional space, so that if it is matching or somewhere it is matching with the query, then it will provide you answer. So the next question can be asked, like how can we find the similarity or dissimilarity of word embedding? So there are some metrics you can use it, like Euclidean distance or cosine similarity. I prefer cosine similarity in most of the cases. because it is a very popular method which finds the similarity between vectors. So you can see here, this is zero point 0.9 and this is zero point 0.6. So here zero point 0.9 and zero point 0.8. So both are nearby, right? So the cat and kitten for this feline can be similar. Okay. The cosine of the angle between two vectors is given here. So the formula is, you can use that cosine similarity is equal to this distance of one particular feature to other feature. Okay. So here you can see this and this are not matching. This and this are also not matching. So it will not trigger this document and not provide you answer from this vector store. Okay. Now you can see here I have taken this example as well of man, woman, king, twin. So these are the words, and word embeddings will convert this into numerical form. You can see here this is the vectors or embeddings, and it will find the dimensionality reduction. So for from this it will just consider highest score which is matching with the other words, and it will store in a vector store, and again it will provide you the answer in a visualization of word embedding. Okay. Here this is also very important topic of reg pipeline, which is semantic search pipeline, because here in semantic search pipeline what it will be doing is, this is a detailed overview. Here also you have to follow some steps, like two steps you have to follow. One is encoding pipeline, and second is decoding pipeline. So you can see here, encoding pipeline will convert the query into the document into text embedders, and again it will be stored to uh, embeddings or vector store. Okay, this is your embedding pipeline. So here in interview, it can be asked like what is the encoding pipeline and how it is useful. So where the reg pipeline has been started, it is your embedding, it is your encoding pipeline, because here you are storing your documents, and you are converting those documents into embeddings, and here you are applying text embedders, and it will again store this embeddings into vector database. Okay, same will be applied to the query, which is your decoding pipeline, and here the query will be converted into embedded query on the fly or search index, and again it will be stored to vector database and re-rank the model, and it will convert this embeddings into readable form, which will be your result. So this is your decoding pipeline where you are decoding your text. Okay, this is again I have taken one example of healthcare chatbot. Here a user will ask query about what are the symptoms of dengue. Okay, so you have already fed some data related to dengue, where you are providing feature details and the solution to it, or many related information to dengue. So first of all, you are just providing documents. You are creating a reg pipeline in which you are feeding some documents. Here I've fed two documents. Dengue often causes high fever. This is the chunks of the documents, and again it is for from second documents. It is getting chunks of common symptoms include muscle pain, rashes, etc. And the re-ranker will like if we are using this, generally I am recommending it to use this for your pipeline, because it will just rank the documents in like in to match the quality. So here here you can see here the symptoms will be provided in the second documents. Okay, so this is the rank will be higher of this document 2, and it will not consider this document 1, because see, in real time data or real projects, there are so many documents, so you cannot find all the information. um, you cannot suggest those all information to user because it will misguide them. Okay. Generator will combines these documents and provide you the answer. Like Tengu is typically characterized. So decoding has been applied here, and it has decoded these chunks into readable form. So dengue is typically characterized by high fever, severe headaches, muscle, and so on. Okay. So this is the advantages of reg. So the feature we can consider is it is updatable, so you can modify your vector store. So in future, if you will modify your vector store, or you can update your data as well. So in future, if a user will ask, they will get most relevant and latest information. It is explainable, you can explain the to your model. It is scalable, you can scale this with your data. And also it is personalized, because here you are providing your knowledge source, so you can personalize or customize it, right? So without retraining LLM model, you can update your database as well. The source document can be shown to the user, so you can provide you a reference of those document as well. It will be used in any domain like finance. If you are using it for finance domain, you can provide you those information related to finance. That's why I have taken two different industries example here. One is from health industry, and one is for manufacturing or industry. Okay. So it will consider only specific history or documents we have fitted to reg. Okay, so these are the main advantages of reg, which is quite different than classic NLP models. So the issue is that if the document it is providing poor document retrieval, so it is using semantic search and embedding. So you see, challenges is like if documents quality is not good, or documents is not providing right in a correct form, then it may provide some wrong information. So in that case, you have to clean your data, and you have to apply semantic search or embedding, so that it will get most relevant information. So to solve irrelevant output issue, you can fine tune the re-ranker or filter your documents. As I have told you, if you are using re-ranker and you are applying some fine tuning, then it will provide you most relevant output. Latency issue is there, so you fast user use fast retrievers and optimize prompt templates, so that it will provide you most latest information. Hallucination are there, because see, if the source and other documents are not updated, then and it is showing sources as well, so there can be issue of hallucination. These are main types of reg. So closed book is there, so which is getting answer from LLM. This type of reg, LLM answers from memory. So here you are not using any retrieval. Again, the second type is open book reg. So here LLM retrieves external documents to assist generation. Okay, so these are some options given to you at the time of building reg. A conversational reg is maintaining context across multi-turn dialogues. So you can use multi-turn dialogues to build some layers into your agents. Multimodal reg is some more different than the layering agents. In multimodal, it will retrieve all the information like images, PDF, videos, or text, any kind of information. Okay.